Glide ratio problems are one of the most common areas where students have difficulties when preparing to take their knowledge test to become a glider pilot. But if you follow just a couple of easy hints, you can turn these tricky problems into some of the easiest ones on the test. On the glide ratio problems, you'll always be given a certain amount of information. The lift to drag ratio, L over D, of the glider, how far you will be flying, or how high up you are. You'll always be given two of these pieces of information and then asked to find the third. Now, the first thing to do is write down what you know, the information that you're given at the beginning of the problem. Next, draw a picture, L over D, okay? Your L over D is how far you go down, okay? And then also how far over you'll go for that. And that forms a triangle. And then finally, what is a nautical mile? Officially, it's 1 minute of arc at the Earth's equator, or 6,076 feet. But you don't care about that. For these questions, it's easiest to just round that off and say that a nautical mile is 6,000 feet. In fact, it's what the FAA does when they write these questions. They expect you to use this approximation to make the math easy so it doesn't take you so long. Now, we're going to look at 3 examples of these types of questions and show you exactly how to solve them. And if this information is useful to you, go ahead and subscribe for more hints and tricks that you can use to become a glider pilot. So let's start with an example problem. In front of us here, we have a stack of printer paper, an E6B, and a mechanical pencil, which is the same items that you'll be given during your test. You have to bring your own E6B, but they'll give you paper and pencil. Okay, let's read the problem. Example 1. A sailplane has a best glide ratio of 30 to 1. How many nautical miles will a glider travel while losing 2,000 feet? As always, write down what we know first, okay? The L over D, lift to drag ratio, is 30 to 1, okay? And we know that we're going to be losing, I'm going to draw a picture. We're going to be losing 2,000 feet. And we don't know how far we will travel. So just put a little question mark there. Okay? Let's draw a picture of our L over D triangle now. Okay? The glider will go down 1 for every 30. That's what L over D means. You go over 30 for every 1 you lose. Well, 1 of what? And let's just label it for convenience, nautical miles on both of them. For every 30 nautical miles you go over, you'll go down 1 nautical mile. Okay? But now we know the answers, A, B, C, and D, okay, the distance is in nautical miles, but the height that we're going to lose is in feet. They give us feet. That's not the same as nautical mile, but we'll use that trick that we talked about earlier, where 1 nautical mile is equal to 6,000 feet. And this triangle and this triangle are still exactly the same, okay? And I'll say that this is equal, this triangle on the left, which is our L over D triangle, feet, okay, is equal to this one, because the ratios are going to be the same no matter what. So now let's write that as we would our normal L over D. L, 30 nautical miles over 6,000 feet equals question mark over here, question mark, divided by 2,000 feet, which was what they gave us in the problem, at 2,000 feet. Well, now we go to our E6B. Okay. 30 nautical miles divided by 6,000 feet. So we turn our E6B find 30 above, and it's 6,000. So we find the 60 and rotate it there. So we've got 30 on top and 6,000 below. We've got 30 on top and 60 or 6,000 below. Okay, now we've got 2,000 below and we want to know what's on top. So we'll rotate our E6B till we get to the 20, which represents 2,000. 2,000 right there on the 20. Okay, and then we look up and it's 10. So therefore, we can say our question mark is equal to 10 nautical miles. Because we just look up from the 20. 30 on top, 60 below, and then we just rotate it while holding it still. 20 below, we look that it's 10 on top. And so the answer is A. You can use a piece of paper for more than one problem during your test. But for convenience, we'll just use one piece of paper per problem. Example 2. A sailplane has lost 2,000 feet. Oh gosh, I really should have done that. Dang it. Ugh! Okay, go back. Okay, so let's do some example problems now. In front of me is a stack of printer paper and a mechanical pencil, which you'll be given during your knowledge test, and I have my own E6B, which you have to bring with you. Let's take a look at problem 1. A sailplane has a best glide ratio of 30 to 1. How many nautical miles will the glider travel while losing 2,000 feet? So, as always, the first thing we do is write down what we know. Okay? L over D is equal to 30 to 1. Okay? And we want to know how far we'll go if we while losing 2,000 feet of altitude. Okay? So we're going to draw a triangle. 2,000 feet. And we want to know how far we're going to go. Okay? So let's look at what information they gave us. They gave us L over D and how high we are up. So that means, so we're always given 2 out of 3. What's the third item? How far we go. Okay, now let's draw our L over D triangle. Okay, our L over D is 30 to 1. So for every 1 that we fall, we go forward 30. Well, 30 of what? Well, we're talking about distances in this case. So nautical miles, nautical miles. Okay. For every 1 nautical mile we go down, we go over 30. But as we talked about in our little tricks, 1 nautical mile, that's not an altitude. That's not what it would look like on our altimeter. We need it in feet, like we have it over here. So we'll just redraw that same triangle, L over D triangle, 6,000 feet, 30 nautical miles. Okay, and that's the same triangle. Okay, because all we've done, we said 1 nautical mile is 6,000 feet. And because it's the same sailplane, we just say that it's equal to this same L over D triangle from above. We come down 2,000 feet and we're going to go over some distance. And we want to know what that is. So now let's write it as a ratio, just as we do when it's L over D. So now it's 30 nautical miles over 6,000 feet equals question mark over 2,000 feet. Now is where we get our E6B out and we solve for the problem. So 30 nautical miles over 6,000 feet. That's what we'll set in. So 30, I'm going to find 30 on the outer scale. Okay, it's on, and it's literally on top. Okay, below it is 6,000 feet. Well, we don't have 6,000, but we do have 60. It's all about ratios. Ratios with the E6B. Okay, so now I have 30 over 6,000 represented by the 60. Now, on the other side, I have 2,000 on the bottom, and I want to know how far I'm going to go if I go down 2,000 feet. So I just rotate the E6B till I find 20, because we don't have a 2,000. Oh, right there. And above it, we want to know the above number is 10. So the question mark is equal to 10 nautical miles, which is answer A. I'm trying to write a little big so everyone can see it, but you can use, they'll give you as much printer paper as you want, so you can do one per problem. You can do multiple questions on a single piece of paper. Doesn't matter. Okay. Example 2. A sailplane has lost 2,000 feet in 9 nautical miles. The best glide ratio for this sailplane is approximately, okay, again, let's start by writing down what we know, okay? It has lost 2,000 feet, so let's draw our L over D triangle. 2,000 feet in 9 nautical miles. Okay, and then the question is, the best glide ratio is approximately what? L over D equals question mark. We don't know what that is. So they've given us a distance that we've gone and a height that we've come down. And now what's the third item? The third item is, what is L over D? So we could do this just as we have before. Let's write what our L over D would be. Well, the easiest way to do that is to say that we're going to go over, oops. Remember, we can't directly divide 9 nautical miles by 2,000 feet, okay, because they're different units. So we're going to use that same hint that we've talked about before, okay? We're going to go down 1, and we're going to go over some distance. We don't know what that is, okay? But of course, if we go down 1 mile, that doesn't help us very much because we need to know what our altimeter says. So we'll go down 6,000 feet, and that will give us a certain distance over that we go. Now we can write this as a ratio. 9 nautical miles over 2,000 feet equals some distance that we go over divided by 6,000 feet, which is the same as 1 nautical mile. Now we take our E6B, okay? We're going to find the 9 on the outer scale, 9. We're going to divide it by 2,000 feet. 9 divided by 2,000. 90 can represent 900, whatever we need it to represent with 9. Okay? Divided by 20, which represents our 2,000 feet. Now, going over 6,000 feet. Up. 6,000 feet, 1 nautical mile, it would go 25, 26, 27. Oops. 27. So 27, okay, is how far it would go if it lost 1. So the ratio, the L over D, is 27 miles, nautical miles, for every 1 nautical mile it loses. The ratio is 27 to 1, which is answer B. Okay. Okay. Let's look at our last question. Example 3. How many feet will a sailplane sink in 15 nautical miles if its lift to drag ratio is 22 to 1? Okay. Okay. How many feet will it sink? We don't know how many feet it'll sink, but we do know that we're going to go 15 nautical miles. Okay. And we do know that the L over D is equal to 22 to 1. So now again, they've given us a horizontal distance that we're going to travel. They've given us an L over D. So what's the thing we have to find? The height. They always give you 2 things, and then they ask for the third. Okay, let's draw our L over D triangle. (22 to 1), which they gave us. Well, 22 what? 22 nautical miles. That's the distances we care about. But again, our altitude, we don't care. We can't really use nautical miles. Altimeters aren't read in nautical miles. So we're going to use our little conversion. 6,000 feet is 22 to 22 nautical miles. Okay, L over D. Remember, we even say it, L over D, L over D. The lift to drag ratio, L over D. Okay. So 15 nautical miles divided by, we don't know how high we need to be up, is equal to, okay, 22 nautical miles divided by 6,000 feet. So let's just set that up on our E6B now. 22 nautical miles divided by 6,000 feet. 22 nautical miles divided by, so we do the 22 divided by 60. 22 nautical miles divided by 6,000 feet, represented by the 60 there. Okay, and now we know we're going to go over 15 nautical miles, and it's on top. Okay, so we're going to look on the outer scale, and then we're going to look for the answer on the inner scale. So rotate, okay, till we find 15 nautical miles on the outer scale. It's the number above, and then we look down. Okay, when I look at that, it looks like there's the 4,000 feet, 4,500 feet, 41, 42. And just a little bit under the 41, but the FAA rounds a lot of these problems off. And look, answer C is 4,100 feet. So the question mark there, okay, the number on the inner scale, the bottom, is equal to 4,100 feet. Answer C. And that's what the FAA wants you to know about glide ratio problems. If you're struggling with problems like this for your knowledge test, you're probably having troubles with other things too. Click on the link below and subscribe to this page for more tips on how you can become a glider pilot.